All right, year 10. So today we are looking at solving quadratic equations algebraically, okay? Now this is most often done when the equation is let equal to 0, which is what we're going to be looking at today. So, we have what is called the null factor law, which is the notion that if you have a number, call it A, multiplied by another number, call it B, and they're equal to 0, then by definition, either A or B must equal to 0, in which case we can treat A and B as being equal to 0 as the two solutions. Okay? So for example, if you have A times B equals 0, if A were 3, B would have to be 0. If B were 7, A would have to be 0. Okay? So what we do is we look for two solutions whereby one we let A equal to 0 and one we let B equal to 0, both of which will be true. Now, you need to recall, HCF is your highest common factor. Okay? DOPS is your difference of perfect squares, is the notion that when you have A plus B, A minus B, that is equal to A squared minus B squared, and vice versa. By inspection, your cross method is when you have x squared plus 7x equals 12, and you're looking for factors of 12, apologies, not equals 12 plus 12. You're looking for factors of 12 that add up to equal 7. So you would take 3 and 4, x and x, where 3 times x is 3x. 4 times x is 4x, the sum of which is 7x. And that matches your middle term. So that you know that x plus 4 is one factor, and x plus 3 is another factor. And finally, we have completing the square, which we've just looked at in the previous chapter. So example 1. We look to solve each of the following for x. Here we have a multiplication where x could be considered to be your a term and 2x minus 5 is your b term. Okay, so it's x times 2x minus 5. Using the null factor law, we know that this means that either x is equal to 0 or 2x minus 5 is equal to 0. So one solution is given already. X is equal to 0. Our second solution, we're going to have to solve for x. So we're going to add 5. And we get 2x equals 5. And then divide by 2. And x is equal to 5 on 2. So from this, our two solutions are x equals 0 and x is equal to 5 on 2. Looking at our next example, B. Again, we have x minus 3 times x minus 7 equals 0. This means that either x minus 3 equals 0, in which case x equals 3, or x minus 7 equals 0, in which case x equals 7. Once we get it to this factorized state of x minus 3, x minus 7, it does become quite simple to solve for x. Finally, in C, we have 2x minus 7 equals 0, in which case 2x equals 7, and x equals 7 on 2. Okay, just to quickly go back, that is 2x minus 7 adding 7 to both sides, and then 2x equals 7 dividing both sides by 2. Our other solution is x plus 2 equals 0, in which case if we subtract 2 from both sides, we'll find out that x is equal to minus 2. Okay, our two solutions, x is equal to 7 on 2, and x is equal to negative 2. B is a step up from that. We have x squared minus 25. Now, this could quite simply be seen as a squared minus b squared. We're going to be applying our dot form of factorizing here. So we can rewrite this equation as x plus 5, x minus 5 equals 0. Which gives us two solutions, either x plus 5 equals 0, and x is equal to minus 5, or x minus 5 is equal to 0, in which case x is equal to 5. Moving on to question C, we get one step harder again. Now, while we do have what appears to be dots, because we have square and square, we do not have perfect squares. Yeah? So 5 is not a perfect square, and 45 is not a perfect square. But there is a highest common factor that we can remove first, and that is 5. So if we divide both sides by 5, the right-hand side will remain 0. The left-hand side will become x squared minus 9. And those are very neat numbers to work with. This is DOP, so we're going to write it as x plus the square root of 9, which is 3, x minus the square root of 9, which is also 3, and that is equal to 0. Carrying this equation up here, we're going to have either x plus 3 equals 0, in which case x is equal to negative 3, or x minus 3 is equal to 0, in which case x is equal to 3. Looking at example D, now here we are going to have to use the cross factor method. So we're looking for factors of x squared, which are only x and x, and then factors of 3, which are 3 and 1. Now, x times 3 is 3x, x times 1 is 1x. When you add these together, you get 4x, so it is a match. 4x, 4x, we know that we have the correct factors. We know that the factors of this are x plus 3 and x plus 1. And that is still equal to 0. From this, we can say that either x plus 3 equals 0, and x is equal to negative 3, or x plus 1 is equal to 0, and x is equal to negative 1. Example A, we have a highest common factor of 3. We have 3x squared, we have 15, we have 18, all of which are multiples of 3. The first thing I'm going to do is divide both sides by 3. Okay, 3x squared divided by 3 is x squared. 15x divided by 3 is 5x. 18 divided by 3 is 6. And that is equal, 0 divided by 3 is still 0. I'm going to use my cross factor method. Factors of x squared being x and x. Factors of 6, which will add to 5, are 3 and 2. Such that we will end up with 3x and 2x, which add to 5x. I'm going to rewrite my equation in factorized form. So we have x plus 3 x plus 2. All equal to 0. If x plus 3 is 0, then x is equal to negative 3. If x plus 2 is equal to 0, then x is equal to negative 2. Now we have 4x squared plus 16x plus 7. There is no highest common factor here. If we take the 4 out, we will end up with 7 over 4, which is not going to help us. So we're going to have to look for factors of 4x squared that when multiplied with the factors of 7 give us 16. So the factors of 7 are pretty straightforward. The factors of 7 being 7 and 1. Now the factors of 4x squared could be 4x and 1x, or they could be 2x and 2x. Now 2x times 7 is 14x. Two x times 1 is 2x. When I add them together, I get 16x, so I know I've picked the right factors. We have 16x, we have 16x. So I'm going to write it out. I have 2x plus 7 and I have 2x plus 1. All of which is equal to 0. This means that 2x plus 7 is equal to 0. If I take 7 off both sides, 2x is equal to negative 7. If I divide by 2, x is equal to negative 7 on 2. That is one solution. Alternatively, I have 2x plus 1 is equal to 0. If I subtract 1, we get 2x equals negative 1. And if I divide by 2, x is equal to negative 1 on 2. Our final example, we have x squared minus 14x equals 2x minus 64. I'm going to handle that in another video as this one's running on to 13 minutes already. Good luck.